Let us apply this the maximin minimax principle of the game in order to solve the following problem. Now let me just define the definition of equilibrium or saddle point. Sometimes the saddle point is called as the equilibrium. It is a position in the payoff matrix where the minimax value of the game is same as the maximin value of the game is same as the minimax value of the game. This one represents the maximum of the row minima, and this one gives you the value of the minimum of the column maxima. So the position in which this V lower bar is same as V upper bar will be called as a saddle point or the equilibrium. The payoff at the saddle point will be called as the value of the game. That means the entry at that equilibrium position or saddle point will be called as the value of the game. Now note down this thing: if the value of the game, if this one V lower bar is equal to V upper bar is equal to 0, then in that case the game is said to be a fair game. However, if V lower bar is equal to V upper bar, that means where V is not equal to 0, then in that case the game is said to be strictly determinable. So let us see whether this following problem is a strictly determinable game or a fair game. So determine whether the following 2% zero-sum game is strictly determinable and fair. If it is so, give the optimum strategy for each player. That means we have, after finding that if it is a strictly determinable game, then in that case we see that what will be the best strategy for A1 and what will be the best strategy for B2 in order to optimize the outcome. So here this is the payoff matrix given in the game. For player B, it is this one. So you can write this one, the first column as B1 and the second column as B2. And the first row you can write it as A1 and the second row as A2. Now here you find out what is the row minima. The row minima from here, what is the minimum value in the first row? It is this one. So you mark it as star. So you write it here -5. And in the second column, this one is the minimum entry. So you write it as -7. Now next you find out what is the column maxima. In the first column, which one is the maximum value? It is this one. We have to encircle that one. And in the second one, we see that which one is the column maxima? 2 is the maxima. So here it will be -5 and this is 2. Now row minima here is equal to row minima contain this set -5 and -7. And column maxima is equal to set of -5 and 2. Now what is V lower bar? V lower bar, it is the maximum of the row minima, which is equal to maximum of this one. Row minima is this one, -5 -7. So what is the maximum value of -5 and -7? It is -5. So this implies that V lower bar is equal to -5. And what is V upper bar? It is the minimum of the row maxima, which is equal to minimum of what are the column maxima in this case. Oh, sorry, here I made mistake. It should be the column maxima. So what are the set of this column maxima? It is -5 and 2. And we see from here that -5 is the minimum entry. So this is equal to -5. Now you see from here that if you this equation and this equation, say A here. So from star and A, we see that V lower bar is equal to V upper bar is equal to -5. Now if you see the definition here, that if the value of V, we see the payoff at the saddle point is called the value of the game. Now from here you see that from this payoff matrix you see that the common value of the value of the game is this one. Why? Because you see that it is both the row minima and at the same time the column maxima, where we have put a star mark here and at the same time we encircle this one. Okay, so this -5 will be called as the value of the game, and since it is not equal to 0, so it will be strictly determinable. That means the game is strictly determinable. And here what we need to find is if it is so, give the optimum strategy for each player. Now this -5 occur in the first row. That means the best strategy for player A is A1, and for player B it will be B1. Why? Because this minus 5 occur in the first column, and best strategy for player B is B1. Therefore, what will be the optimum strategy now? Therefore, A1 B1 is the optimum strategy for this particular game. Why A1 B1 means that the best strategy for player A will be A1 and the best strategy for player B will be B1, because here if they apply the if player A apply the strategy A1, then he will get a maximum gain, and then for player B, if he play this strategy B1, that means this one, it will give you the minimum loss. So therefore, whatever strategy played by player A and player B, the best strategy here to optimize the outcome will be this one, A1 B1. Hope it is clear now. This is application of that maximin minimax principle.